Hello, this is Miss Rossman. I've created another video for you today about solving equations. Enjoy. If you've ever seen a scale before, you may have noticed it is a device used for weighing objects. It has a balance beam and two pans, and when the pans contain exactly the same mass, the beam will be in balance. When the pans contain different amounts, the beam is unbalanced, just like this picture shows. So suppose we have a scale that has 5 coins on the left and 3 coins on the right. And we want to know that what amount do we need to add to the right pan in order for the scale to be in balance? You probably said 2 because 3 plus 2 equals 5, and it only makes sense that 5 coins would be in balance with 5 coins. This is the same logic that we can apply to solving equations. So, for example, if we have an expression like 22 equals 9 plus n, let's think about it in terms of a scale. We have 22 things on the left, and they're in balance with 9, plus n things on the right. And the goal of solving equations is to figure out what does n equal? What is this unknown amount? So in order for us to solve for n, we need to think about how can we get n all by itself. We can do that by subtracting 9 from that right pan. If we subtract 9 from that right pan, then we can get n all by itself because 9 minus 9 equals 0. But if we just subtract from the right pan, we're going to have our scale be unbalanced now because we only subtracted 9 from the right. 22 is then greater than n. To help solve this problem, not only will we have to subtract 9 from the right pan, but also from the left, just like this shows right here. And if we figure out what does 22 minus 9 equal, it equals 13. So 13 must be in balance or equal to n. The method we just used to solve for n is called solving by inversing. Although you could have used other methods to accurately find what n equals, we want you to start getting used to how using solving by inversing because expressions are going to get a lot more complicated as we continue on. If you don't know exactly what solving by inversing means, that's okay. I'm going to go over a few more examples in a little bit. But just to start off with, we want to go over like the two principles about solving by inversing. The first principle is that we want to use the opposite order of operations, and the second principle is that we want to use the opposite operations. So in order to know what the opposite is, let's talk about what the regular is. So the regular operations are add, subtract, multiply, divide. When we talk about the opposite operations, well, the opposite of add is subtract, the opposite of subtract is add, opposite of multiply is divide, and the opposite of divide is multiply. In order for you to understand the opposite order of operations, we first need to review the regular order of operations. So you may recall from previous years that the first thing you do in each expression is anything in the parentheses. Second, you would do the exponents. Third, you would multiply and divide. And then fourth, you would add or subtract. If you take the first letter of all those words, you get PEMDAS, which you probably remember using to help remember the order of operations. Well, the opposite order of operations would just be SAD/MEP. Subtract, add, divide, multiply, exponents, then parentheses. So let's go ahead and apply those two principles to solving this expression 37 equals 5 times x plus 2. Now remember that x is some unknown amount that we want to try to figure out. And the point of solving by inversing is to get x all by itself so that we know what x equals. So let's look back at that first principle. We want to use the opposite order of operations. Well, if you remember, the opposite order was SAD/MEP. So we want to look back at the expression to see if there's any place where there's subtraction or addition taking place. So if we look back at the expression, then sure enough we will see that there is an adding 2 taking place. So we know what we need to tackle first. Now we want to think about that second principle, which is the opposite operation. Well, the opposite of add is subtract. So we want to subtract 2 from both sides. And the reason why we subtract 2 from both sides is, well, we can think back to that scale where we had to keep the scale balanced. Subtracting 2 from both sides just makes it balance. So if we minus 2 from 37, we get 35. And if we take 5x plus 2 minus 2, we are just left with 5x because 2 minus 2 equals 0. So we're left with 35 equals 5x. Again, we want to remember that the goal is to get x all by itself, so we have to think about what operation is taking place between the 5 and the x. Well, whenever you just see 5 and x right next to each other, we can assume that it's multiplication. So we want to think about, well, what is the opposite of multiplication? Well, the opposite is divide. So let's go ahead and divide by 5 on both sides. Again, we want to remember both sides. Well, 5x divided by 5, the 5's cancel out, so we're just left with x, and then 35 divided by 5 equals 7. So overall, we're left with 7 equals x. And we can go and plug 7 back into the equation to just double check to make sure if we're right, but we don't have to right now. I'll do that for our last problem. Now the final expression we're going to solve together today is 58 equals 3 times the quantity of r minus 8 plus 1. Remember, the goal in solving by inversing is to get r all by itself because we want to know what r equals. So to do this, let's just look over the expression and pick out all the operations. Well, we see that there's multiplication, there's subtraction within the parentheses, and there's also an addition. So if we think back to that first principle about opposite order of operations, SADMEP, we know that the first thing we want to take care of is that addition. The second thing would be the multiplication, and then the final thing, or the third thing, would be the subtraction that's within the parentheses. So if we think to that first thing, the addition, we want to think about what is the opposite operation of add. Well, the opposite operation is subtract, so we want to go through and subtract 1 from both sides to keep the expression balanced. And we would get 58 minus 1 is equal to 57, and that 3 times the quantity of r minus 8 plus 1 minus 1 would leave us with just 3 times the quantity of r minus 8. So we're left with 57 equals 3 times the quantity of r minus 8. So now let's think about that multiplication that's taking place between the 3 and the r minus 8. Well, the opposite of multiplication is divide. So let's go through and divide 3 on both sides. And we're left with 57 divided by 3 equals 3 times the quantity of r minus 8 divided by 3. Well, 3 divided by 3 is 1, so those cancel out, and we're left with 19 equals the quantity of r minus 8. But whenever it's just the quantity of something, the parentheses can go away, and we're just left with 19 equals r minus 8. Now, in order for us to continue to solve for r, we need to get rid of that minus 8. So the opposite operation of subtraction is addition. So we want to go ahead and add 8 to both sides. And we would get 19 plus 8 is equal to 27, and r minus 8 plus 8 is equal to r plus 0. So we're left with 27 is equal to r. Now that we found our answer, probably the most important step is to take our answer and go back through and double check to make sure our answer is correct. I know I didn't have you do this in the expression before, and that was mainly because of time, but I want you to get in a really good habit of double checking your answer because it's really, really important that you know your answer is correct. So in order to do this, we would just take our regular expression and take the answer that we found and plug that back in for r. So we would get 58 equals 3 times the quantity of 27 minus 8 plus 1. And then we just use the regular order of operations to evaluate this expression. So we would get 58 equals 3 times 27 minus 8, which is equal to 19, plus 1, and then 3 times 19 equals 57, and then 57 plus 1 equals 58. So you get 58 equals 58, so we were right. So good job, 27 really does equal r. Now it is your turn to practice. I've created 4 different problems for you to work on. The fourth one is probably the most challenging, so good luck with that one, but go through, see what you can do with these problems, and remember to double check your answer. That will help tell you whether you were right or not. You can also feel free to leave questions or comments below in the comment bar if you'd like. Good luck.